the probability of x less than or equal to x is what? It is the probability of event for x less than or equal to x. Okay, so what is this value? This value depends on x value. Okay, so it is function of x. This function, how do we denote? This function we denote it as fx of x. Okay, this fx of x is called cumulative probability distribution function of random variable x. Okay, so what is cumulative probability distribution function? Is defined as fx of x is equal to probability of x less than or equal to x. Okay, so instead of calling it as cumulative probability distribution function, we can also call it as distribution function of x. Okay, so here x value, here we have discussed that probability of x less than or equal to x, this small x value will be any real number. It can be range from minus infinity to plus infinity. Okay, so it is having some specific properties, so we'll be discussing all these properties. What is the first property is fx of minus infinity will be 0, fx of infinity is equal to 1, and fx of x will be having the value between 0 and 1. Okay, and we also discussed that if x1 is less than x2, if x1 is less than x2, then fx of x1 will be always less than or equal to fx of x2. Okay, and here the fifth property is that probability of x1 less than x less than or equal to 2. Okay, probability of x1 less than x less than or equal to x2 will be equal to what? It is fx of x2 minus fx of x1. These are the five properties of distribution function. Okay, and we have one more property, that is fx of x inverse. Okay, fx of x inverse will be always equal to fx of x. These are the six properties of distribution function. Now we'll discuss the properties, proofs here. So what is the first property? Fx of minus infinity is 0. Okay, so what is fx of minus infinity? It is nothing but the probability of x less than or equal to minus infinity. What is fx of x? My fx of x is nothing but probability of x less than or equal to small x. Okay, what is the so that is why here small x is equal to minus infinity, no? So probability of x less than or equal to minus infinity. So since we don't have any elements before minus infinity. Okay, so the event x less than or equal to minus infinity is impossible. So what is the probability of x less than or equal to minus infinity will be 0. Okay, so this is our first property. Now we'll discuss the second property, that is fx of infinity is equal to 1. Okay, that is fx of infinity is equal to what? It is probability of getting x less than or equal to infinity. Yes or no? And what is this probability of x less than or equal to infinity? It will include all the elements in the sample space. Okay, so it will be including all the elements in the sample space. So it is nothing but the sample space. So it is probability of sample space. So what is the probability of sample space? Will be always equal to 1. Okay, so if x less than or equal to infinity means it will be it will be including all the events possible, that is it will be including the sample space. So probability of sample space will be equal to 1. Okay, so the third property is that 0 less than or equal to fx of x less than or equal to 1. It means that the distribution function will be having the value between 0 and 1. Okay, so we have seen that fx of minus infinity is equal to 0, means that is the minimum value. Fx of infinity is equal to 1, that is the maximum value. So it means that the distribution function will be having the value between 0 and 1. Okay, now what is fx of x1 less than or equal to fx of x2 when x1 is less than x2? Okay, so for example we are taking two events. For example, here we are throwing a die. Okay, so we are getting the outcomes like this: 1 2 3 4, 5, 6. Okay, these are the possible outcomes we are getting whenever we throw a die. Okay, so for example, our x1 is defined here. This is our x1. Okay, this is our x2. So what is x1 value? X1 is less than x2. X1 is less than x2. So what is the probability of x less than or equal to x1? X less than or equal to x1 will be equal to what? It is equal to 1 by 6 plus 1 by 6 plus 1 by 6. It is 3 by 6. Okay. And for example, we have taken x2 here. So what is the probability of x less than or equal to x2? X less than or equal to x2 is equal to what? So here it is 1 by 6 plus 1 by 6 plus 1 by 6 plus 1 by 6 plus 1 by 6. Okay. So it is 5 by 6. So what is the probability of x less than or equal to x2? Will be always greater than probability of x less than or equal to x1. Okay. So if you have chosen x1 less than x2 like this, then what is fx of x1 will be always less than or equal to fx of x2. Okay, it means that fx of x is non-decreasing function. Fx of x will be always increasing function. It is non-decreasing function. Okay. So now if you want to find out x1 less than x less than or equal to x2, that is fx of x2 minus fx of x1. Okay. So x less than or equal to x2, how do you write, ma? Say x less than or equal to x2. Say here we have defined the sample space like this. It is having the values 0, 1, 2, 3, x1 is at 1, x2 is at 3. Okay, so how do you define x less than or equal to x2? We define it as x less than or equal to x1 union x1 less than x less than or equal to x2. Like that, this complete range we divide into two parts: x less than or equal to x1 union x1 less than x less than or equal to x2. Like that we will be dividing. So what is the first one? The first one is nothing but fx of x1. Okay. So it is plus, what is this? It is the probability of x1 less than x less than or equal to x2. Okay. Now what is the probability of x1 less than x less than or equal to x2 from this equation? From this equation we are finding, from this equation what is probability of x1 less than x less than or equal to x2 will be fx of x2 minus fx of x1. Then the last property says that fx of x plus or fx of x inverse will be equal to fx of x. So it means that the distribution function is continuous function.